All right, welcome back to another installment of our tutorials. This time we will try to figure out how to model a part. So let's just look up some simple CAD parts, and we'll try to model it in FreeCAD over here. See if we can maybe make something. Oh, these ones switch around. Oh, it's a GIF. Okay. Or a GIF. Who knows how it's pronounced. Oh, let's do this one. This one is reasonably complex, right? Alright, so let's see. Open image in new tab. There we go. Yeah, let's try to make this thing. Okay. So the first thing you want to do is you want to break it up. You want to take a look at it, you want to take inventory, and you want to see which parts you're gonna try to do first, right? So the way I would go about it is I would first, well, me personally, first I would look at this shape. You got to break it up into several shapes. So you see this kind of rectangular bit. We can take care of the curves and everything else later. You want to break it up into as simple pieces as possible. So you have this rectangle of sorts. I hope you can see it. My drawing skills may be a little lackluster, but I think it should be fine. So this is what I'd first do it. This is what I'd do first, is I'd make this prism, and then on this prism I would add on this part and this part. I would extrude it out. Again, another rectangle. Actually, I'll show it to you once we'll cross that bridge when we come to it. But first, this is how I would do it. I would take this part and this prism rather, and work from there. Okay. So let's go to create new. Here we are in our regular project space. Here we have start, and we go into part design like last time. Let it load up. Okay, create body and create sketch. We want to choose XY plane. Do we? Okay, let's put it back into orthographic. Isometric, yeah. Alright, XZ. XZ would be better, I think. Yeah. Okay, actually, let me go back. Close. Right on. So right back to here. So see how in an isometric view you can see these three principal planes. This is what is shown right here. So you have both the planes and the figure. This is kind of looking at it from an isometric view, from a kind of like the way we're looking at it right here. So if we want to start building it from using this side, this face, we need to choose the XZ plane. That was my reasoning behind it. Okay, so going back. Right on. So we'll first make a rectangle. Doesn't have to be pretty because we'll constrain it later. Horizontal, actually, yeah, this. Horizontal constraints, length should be 4.5. That 4.6. Okay, first you need to do some math because it's measuring from this edge to the center of this, but we know the radius is 0.8 from here to the edge. So what we want to do is do a little bit of mathematics. So take 4.6. We don't know if this is in inches or millimeters or whatever. We're working in millimeters, so that's what we'll do. So we take this distance plus R8, because it's a circle. This distance would be the radius, plus 0.8. That should give us 5.4. Because we're doing with millimeters, we'll just leave it as millimeters. So that is the distance that we have right here is 5.4 rather. 5.4. Okay, and yeah, I'll just zoom in. 17.2. No, we need 0.6. 0.6. Boom. That's shrunk it down quite a bit, hadn't it? Okay. Now, because it is unconstrained, we can move it around to our heart's content. Let's make these two coincident. Yep, coincidence constraint. Oh yeah, it only works with points, doesn't it? Okay. Or not. Okay, yeah, I remember. Yeah, coincidence. Why? What do you want? I'm tired, man. Leave me alone. Okay. Select these 2 points, make them coincident with each other. There we go. Alright, now we have this shape kind of constrained right here. We have these arbitrary measurements done. There you go. Got 0.6 millimeters right there. Okay, so we have this plane sketched out. So close, and we have this nice little plane for ourselves. There. So what we want to do is pad it. Whoa. Okay. Reverse. Make it go in that direction. Okay. So we want the length to be. No, come on. Oh yeah, that's a little note for myself in case I forget how to end the recording. Okay. Okay, let's see. So the radius is 0.9 right here. You see the radius is 0.9, which means this length would be the radius times 2, because from the center out. So radius times 2, that's going to be 1.8. So we can go 1.8 in that direction and have ourselves a nice rectangle from which we can build on, onto. Right. Let's see. Now we can choose which what we want to do. We want to start building this on or this one. Let's do this one first. Yes. Okay. So now we have our piece ready. We can start adding on the big things. So we select this surface that we want to sketch on. Click New Sketch. If I can remember where it was. Okay, yeah, so green. Yeah, if we're looking at it isometrically, which means we should be drawing right here. Okay. If I could remember how to make it perpendicular, that would be pretty swell. Oh, we just do that. Okay. All right. So if we can imagine this being where we need to start, yeah, this corner being this corner, because that's how it's fitted. See, that's where the origin is, and that's kind of that point right there. Right. So that's where we'll start to work on. Right on. So what we'll do is we'll do a rectangle again, because that's how we usually build things, is with rectangles. Create a coincidence constraint between these 2 points. There we go. Create a distance constraint right here. Okay, because we need the thickness, because it's going in this direction, that will be 0.6. So we type 0.6 in. There. Okay. And to get this constrained, all we got to do is take this distance, which we remember to be 1.8. 1.8, and there we go. Our shape is fully constrained right here. And so now it should be drawn, yeah, it should be drawn on this this surface, this plane right here. And what we do is we pad it. Oh boy. Yeah, that's pretty big. Alright, so going back down. We'll look at the design. Okay, So it's wanting 1.0 from the bottom, and then from here on it wants another 0.9. So that should be 1.9 millimeters. Doing a bit of quick math, and we get that. Yep. There we go. Looks to be acceptable so far. I have a cup of tea with me and a can of Sprite, which I'll hopefully finish by the end of the video. But if not, I'll show you some cool tricks at the very end of what you can do with these parts too. Okay, so okay, let's build on this part then. Right, so we have a 2.4 going from this edge to this edge. See these construction lines? Yeah, these lines are called construction lines because they don't define the part necessarily, but they help define the boundaries of each part. Okay, so going back, we will try to get this part done, this kind of prism object done. Not the circle, not the one with the semicircle, but just this additional portion we'd like to carve out. And for that, we need to do a bit of quick math again. So, getting out a trusty thing. So this measurement right here, this was 1.9, right? No, 1.8. Yes, I can do math. I promise. Okay, so yes, that would be r is equal to 1.9. Okay. And so we have 2.4, which is the total distance. I have 2.4 minus this distance. But we also have to subtract this thickness as well, because we're trying to get the thickness of this prism that we're trying to make. So we would subtract 0.6 as well. Plugging that into our calculator. Hold on a minute. That would equal 0, wouldn't it? Okay. What's going on here? There's also a possibility that I'm just interpreting this incorrectly. Just so you know, engineers are notorious for making their drawings confusing. But, okay. Perhaps what this is trying to say is that it's construction line going to this edge right here instead of this this plane. So let's assume that and say that that's how we interpreted it. Okay. Right on, so that should give you 0.6. So this, the area that we're trying to measure, again. So yeah, imagine this prism that we're trying to get. So this would be 0.6 as well. Okay. Select the surface. Create. Yeah, path parameters. Yes, that's fine. Okay, click on the click on the surface. And there we go. Let's start making another rectangle. But now, okay, give me a second.
All right. So, remember that one time in the previous one where we couldn't constrain this line to this edge? Apparently, thanks to this wonderful person, we can apparently use this tool, which creates an edge linked to an external geometry, which apparently makes it so we can use external points to actually constrain your part, which is wonderful news. So you take this, select this point, click Control, select this edge. So see, you can now select this edge and click this. You don't want to create this coincidence constraint because that's apparently for points. This one is a point on an arc. It fixes a point onto an object. See, fix a point onto an object, and now it snaps it on the line. So yeah, likewise you can do this and this, and snaps it there. This, click this, and create this line. Basically, it's basically a construction line, which is different from regular lines, because construction lines, they help you just, well, I told you where the construction line is. It's these things. Okay, yes. Right. Okay, moving on. Yeah, that's gonna make our lives infinitely easier. Okay, so have this line. Okay, we have 1 degree of freedom. What degrees of freedom basically mean how free is your part to move around. So 1 degree of freedom means it can only move around in this direction, which is in this direction. Cannot move in this direction because we have it constrained. We cannot move in this direction because we have it constrained, and it cannot move anywhere else. It can only move, change in this direction. So what we got to do is you got to imprison it, so to speak. Right, so have 0.8, so that multiplied by 2, that's the radius we're trying to find. From here to here, that's 0.8. So from here to there would be 0.8 times 2, which is 1.6. So have 1.6 millimeters. There we go. Okay, there we go. That should be better. Okay, and we pad it out to not 10 millimeters, but to 0.6. That looks to be right. That looks to be correct. So see how it's sort of taking shape? Yeah, so it's getting there. It's not perfect, but it's getting there. Okay, continue on building the parts piece by piece. Okay, so now I have to create 1.5 towards the center plus radius 1.8. So 1.5 plus 0.8, that will give us 2.3. So we go back to here, make this distance, before we forget, 2.3. Oh dear, okay. Use these to make, oop. Oh geez, you can select 2 curves and 0 points. Right. Forgetting we gotta use points instead of curves. Okay. Do this. Yep, select this edge. This tool, edge linked to an external geometry. Yeah, I have a feeling this tool is gonna help us tremendously. Okay. Select the curve constraint. This to this. Boom, snapped. Create this one as a construction line. Do the same thing with this. There we go. Now it is constrained. Okay, we exit out, just click close, and time to pad it. Oh, and it was 0.6. Yep, see this distance is 0.6. Okay, now we have the rough general shape of the part ready. Now we can start chiseling away. Click OK. Select this. Nope. Select this surface, and we're gonna sketch on here. Ah, that's curious. Okay. Sometimes you have to tilt it around to make sense of the part, but it's okay. Nope, that's not the view we wanted. Oh geez, okay. So we're trying to look at it from the right side. There we go. Now we should be able to do a constraint. Okay, so actually better yet, let's do a chamfer. Chamfer, yeah, that's what it's called. Yeah, rounded. Make a fillet rather. Okay, fillet. Select these 2 edges. Yeah, there's 2 ways that you can go about making these semicircular things. You can round them off, or you can cut them off. Basically, this will round them off. But if you want to cut them off, you'll go into Sketcher, make a semicircle right here, make a part that goes from here, round down this edge and round back. This kind of like semicircular triangle. And actually, let me draw it for you. Right. Yeah, there we go. So you have this part right here, right? I won't draw it on here because it's going to take so much time. But basically what you would do is you would create this. Oh geez, that's atrocious. Okay. Yeah, let's pretend that this is a good drawing. So what you'd basically do is you'd create this shape right here. Oh, yeah. Create this shape with actual measurements, of course. Make it constrained as much as you can, and you would pocket it. You would pocket it with this tool. Select the sketch, create a pocket, and that should take it off. But I personally find it easier to round it off instead. So what you would do is create those two with a radius of 0.9 for this time around. 0.9. Is that so? Okay, I suppose we'll just do it one by one. 0.9. Okay. Yep, that's a 0.9 radius fillet. And this is also 0.9 radius fillet. It'd be really nice if you would cooperate. Okay. Right, these are, we don't need these sketches, so we can easily delete them. Okay. Oh dear. Okay, cancel that. We need, why don't you want, okay. 0.9. Okay, give me a second. Alright, so I believe it is a weakness of FreeCAD apparently, but fillets are generally really picky, so it'd be better to go with a pocket extrusion method. But what I found, and I guess it should work just fine, it's probably just a weakness of the model that a weakness of the geometric modeling kernel, whatever that is. CAD kernel, creation of 3D shapes. Yeah, so basically like it's a weakness of FreeCAD. Basically, one way to get around it is to just make it very close to what you're trying to do, or just add a bunch of 9s to it so that it's close enough that you cannot really see it, but it's still kind of done. It's still kind of there. That's the closest I could think of. So, alright, so what you got back here, now that we have rounded this off, we can go in here and make a circle. Right, so this has a diameter of 8, and it's centered, presumably. Yes, okay. So go make a sketch. Nope, make it upright. Alright. Circle. Alright, now we can use my favorite tool and basically make these 2 points. Oh no, we do not want them to make them coincident. No, we need to not make it that. These 2 points. We need to find the vertical distance. Is that vertical distance? I need vertical distance. Oh no. Ha! I need them vertically distant. Okay, I suppose it's fine. we'll just have to find another workaround. Okay, so we'll take this construction line, make that, and do vertical distance from this point to this point. Okay, what? This is not what I wanted. Oh no. Okay. Okay. Oh, okay. It's because our geometry is tilted. That's why it's mistaking it. Okay, so take this and this. Yeah, because this is horizontal apparently, and because we have changed it, that's why. Okay, so it'd go to 0, and that should make this centered. I want distance from here to here, which should be 1 radius. So take a point from here. Let's do it to this point. Right, and that should be our radius, which is 0.9. 0.9. We're measuring the distance from this center point out here. And that is given to us by this measurement right here, radius 9. Okay, now I want the diameter of this hole, which would be... It does not make sense. Okay. Oh my god. Okay. Oh, yeah. I forgot. So, click on this. There we go. Constraints. Property. How come there isn't a radius? Because there should be a radius in here somewhere. Oh, right. Ha, I forget this. Okay, constraint diameter. Right, this should be 0.8. I am still learning, but yes. See how this is green now? So, tasks close. And now I can safely pocket it. Boom, there we go. Dimension through all. Yeah, dimension should be fine since it's 5 millimeters. This is less than 5 millimeters, so it goes through the whole thing. All right, click OK. There we go. Again, we could go over here, sketch. Yeah, let's do it my favorite way. Let's see. This is radius 0.8. 0.8. Okay, and this one will do 0.79999. 0.79999. You don't want to go overboard because then it's going to round up again. And so yeah, I think 4 nines should be enough. Yep, there we go. That should get it pretty much close enough without the computer freaking out. So, okay. Going back to sketch mode. You should know the drill by now. Create, define these lines. And then don't necessarily need to do that because it's on the axis. Right click to remove. Circle. Bam. Constrain vertical distance of this point and this point. Should be 0. There, constrain this, their horizontal distance, cancel that. Horizontal distance of this point and this point should be the radius, which we decided was 0.8, I believe. Yep, there we go, centered it. Diameter of a circle. Right, we needed it to be 0.6. Yes, this symbol means diameter. Whenever it says R, that's generally radius. So 0.6. 0.6 as the diameter. Boom. Green meaning it's fully constrained, which means it doesn't have any degrees of freedom. And pocket it. Boom, there we go. Another hole. Another hole down. Okay. Let's see. What else do we need? Right, so we need this hole in the center. Okay, we select this face. Oh, yeah, click OK. Yeah, it was still in pockets, so. Okay, click, oh, select the surface. Click sketch. Alright. So we were looking at it from that direction. Basically, yeah, because this is the raised bit, and that's the bit that's below. So need to create a. Ooh, my throat is not feeling so good. Whew, okay. Let's see. We could just do this tool, I believe. Ha! Would you look at that? That's exactly the kind of shape that we needed. All right, now let's see how we can constrain this. Okay, so we need this length to be 0.9. 0.9. Okay, let's move it around. Yeah, see? Still has 3 degrees of freedom, which means there are 3 different places from where we can edit it. Okay, so it has 2 times radius of 0.3. So this has a radius of 0.3, and that has a radius of 0.3. That's what it's meant by 2 times. So, okay, you would take constraint radius 0.3, and there we go. It has 2 degrees of freedom. Let's see. You can move around like this. You can move around in the x direction and the y direction. Okay. Ah, someone's texting me. Ah, it's a friend of mine from Finland. Hope she's doing all right, but I'm kind of busy right now. So, okay, right now we got to constrain it in this direction. So 0.9 be from the edge. Again, my favorite tool, because it gave me so many headaches last time. I wonder if you could do this. Oh wow, okay. So you can make. Oh no! Don't select the surfaces. Ah, that's phenomenal. Okay, I'm getting sidetracked. Okay, so you take this point, center point, because it's measuring to the center line right here. So 0.9. Click Control. Click this. Select this line. 0.9 millimeters. There we go. Again, we can move it in this direction still. So this would be 1.9 from this edge, which should be this edge. But we can just use the this axis. Select those two. Click horizontal, and it was 1.9. Boom! Yeah, there it is. There's the measurement. There we go. Fully constrained sketch and pocket. There we go. Alrighty, alright. Okay, now I believe we have almost everything done. Now I have to get these various edges dressed up. So now we have a radius of. Oh, come on now. Why are you texting me? There we go. Put it away. Okay, radius of 0.4 would be on this edge. So move it around. Zoom in. Hopefully it wouldn't give us any problems, but something tells me that it will. I wonder if you could select 2 faces and create a 0.05. Okay, it doesn't like it. Okay. That's okay, no big deal. What we could do is we could sketch on this plane. And what we do is we basically add an arc. So we would take a center right here, push it out to here, say somewhere perpendicular. Yeah, whenever it lights up in yellow like that, that is when you know it's constrained. I suppose it doesn't really matter that much, you're gonna constrain it anyway. So, okay. Okay, make this constrained with that. Make the radius, let's see, 0.4. Like so. And constrain those 2 points. Right, so we have 2 degrees of freedom still. Kind of move it around, see where it's going. I suppose it has an angle, right? That's this, I believe. Yes. Okay. Though I do not imagine there really... Oh, hush. Though I don't imagine there being an angle that would constrain them to be like that. There we go. Should be 90 degrees. 90 degrees because this is a 90-degree angle. 1 unit of freedom still. I cannot figure it out. Aha, okay. That makes sense. Okay, so we got to constrain this distance as well. Oh, how would we do that? I need a minute to think about this. Right on. So apparently the way math works is you could basically take a distance from here to there and make it the same as your radius, and that should put you on a good course to intersect it. Okay. Now, because it's not a closed shape, it's probably going to complain. So what we would do is we would create... I don't want to risk it, so... create these 2 lines and make them coincident with each other. Nope. Make them coincident with each other, and then make them put them there, and this one can connect stuff there. There we go. Now we have a closed shape. Select close. Right. How thick did we make it? We made it 0.6 thick. So we could pad it 0.6. Question mark. Oh, right. You gotta select the sketch. Ha! Okay. Yeah, gotta select the sketch. Oop, nope. Go back. Select the sketch and then pad it. 0.6. No. Oh dear. Oh man. It's okay. Still learning, right? Yeah, they could really make it better. Okay, symmetric to plane. Oh dear. Okay, something happened. 0.6. Oh no. Okay. 0.6 like this. There we go. There we go. I suppose that works. Okay. Now for the easier one, hopefully. Click that. There we go. Rounded it off to radius of 2. Okay. Radius of 2 millimeters. Click OK. Was it 2? It was 2. but it doesn't want to give us to. So let's make it 0.5. That work. 2 millimeters. Haha. Haha. Come on now. 1.5. Something's really weird. Okay. Again, they might have this a little wrong, a little incorrect. That's what my hunch is, because that's a very big radius for that that kind of. It just doesn't look right. That's what I'm trying to say, basically, because this looks very similar to what you would have for here or for there, not 2, definitely not 2 millimeters. So basically, what I would do is I would just put it as 1. Yeah, no big deal. But this is what we have so far. We have this part basically done. There was a way to remove. No, come back. There was a way to remove these lines, these intermediate lines, but I haven't yet found a way to do that yet. But I suppose that'll be a topic for some other time. But what I really wanted to show you is how you would go about printing this thing. So after doing a bit of research online, I found out that you need an .sl something file. Okay, but I'll know when I see it. Okay, please select the list of objects that you want to take out. So you click on this. Select the body and click export as the STL mesh rather. Yes. Okay. So you go to here. Name say it as part 1, for example, as an STL mesh. So an STL is what your slicer will most likely take. And slicer basically the program that separates the part into layers. So yeah, so you need to export your files as STL files. And there you go. So my program, Katia, it does that too. So here we have part 1, double click on it, and it'll open up 3D Viewer, which is a program by Microsoft, exclusive to Windows 10. And there you go. There's our part that we have made in that is interesting. I wonder why I didn't include the fillet there. Okay, let's try it again. File, export, of course, the whole body. Yep, selected that file. Export, STL as part 1.1. There we go. Now it's ready. Maybe just didn't have enough time to get its act together, but who knows. This really interesting thing is mixed reality. So here's me, and here's the part that we have created. Some quick animations you can do is you can make it go on a turntable, make it turn around. That's pretty neat. Swing. But yeah, that's basically what it does. Is it allows you to view this allows you to view this part from FreeCad. Right. Okay, I suppose that's it. Yeah, I believe that is all. all for now.